Welcome to Module 15, Part 2. In this section, we're going to be looking at how to do hypothesis tests specifically for proportions. So recall from Module 12, p hat is equal to x over n. The mean of the distribution of p hat is equal to p, which is the population proportion. And the standard deviation of p hat is the square root of p times 1 minus p divided by n. The central limit theorem for proportions, which is how we verify that we have a normally distributed distribution, so our symmetric bell curve, is n times p must be greater than or equal to 10, and n times 1 minus p must be greater than or equal to 10. If either of these are not true, then we cannot proceed because we do not have a normally distributed distribution. And then finally, our z-score for proportions, z equals p hat minus the mean divided by the standard deviation, or p hat minus p divided by the square root of p times 1 minus p over n. There are two methods to a hypothesis test. We are going to focus only on the p-value approach. We're focusing just on this because it's easier and it gives you the same answer as the other one with less headache. So in the p-value approach, we're comparing the probability of the results from our sample to a level of significance, or alpha. Notice alpha is the same value we used for the type 1 error. So if the results from our sample are less likely than alpha, then we reject the null hypothesis. So in other words, we're looking at what is the probability of getting the results that we got if we assume that the information we have about the mean previously is correct. If the probability of our results is too small, then we say the information from the previous studies must be incorrect. So there are 4 steps to a hypothesis test with the p-value method. The first step, and I apologize, it got a line through it. I couldn't undo it. So the first step is to give the null and alternative hypothesis. The second step I've actually changed, and I forgot to change my notes. So I used to make you draw the curve, but I'm not going to do that anymore because it doesn't really help all that much. What we need to do instead, that I've kind of been skipping over, is we need to verify normality. We need to use the central limit theorem to make sure we have a normal distribution. Because if we don't have a normal distribution, there's no point in moving on, because it won't be correct. So once we know we have a normal distribution, we can calculate the test statistic called z data and the p-value for that test statistic. I'm going to show you in the notes how to do step 3 by hand. In the calculator tutorial guide that I will post with this, I will show you how you can do step 3 quick and easy. Okay? And then finally, step 4, give the conclusion, either reject or fail to reject, also called do not reject, and interpret the results. So let's go ahead and get into an example. So the first example says, the Center for Disease Control and Prevention reported in 2010 that 20% of Americans smoke tobacco. A random sample of 400 Americans was found, and from that sample, 76 reported that they've smoked tobacco. Test whether the population proportion of Americans who smoke has decreased since 2010. Use a level of significance of 0.10. So important pieces of information. There's a lot of them. So let's highlight some stuff. So first of all, it was previously reported that 20% of Americans smoke tobacco. We took a random sample of 400 Americans and found that 76 reported they smoked tobacco. Test whether the population proportion, so population proportion tells us the parameter of Americans who smoke has decreased. Use a level of significance of 0.10. So that 0.10 is our alpha. Okay, let's write that in. alpha equals 0.10. All right. So let's get started. So step 1, write out the null and alternative hypothesis. So step 1. Oop, oop, oop. Okay. So our null always starts with an HO. We're testing a proportion, so that's P. And we're going to assume that the information from 2010 is still valid. So we're going to assume that P equals 0.2. And then our alternative, I'm going to write it over here. It doesn't matter. You can write it next to it or you can write it below it. P decreased means gone down or less than. So P is less than 0.2. So we have our null and our alternative. Now I want to go ahead and verify that I have a normal distribution, because if this isn't normal, then I don't even need to continue. So for that, we need to take n times p. So our n is 400. That's how many people we surveyed. And p equals 0.2 from our null. Multiply those together, and we get 80. 80 is greater than 10, so we're good there. Second check, 400 times 1 minus 0.2, and that should give you 320. I didn't actually do it, so let me actually do it real quick. 320. That is also greater than 10, so this is normally distributed, which is good. It has to be normally distributed for us to be able to move on. So now, step 3, we still need that information. I can't scroll that far down. Step 3, we're going to calculate a test statistic or a z-score, and we're going to calculate a probability. So our z-score equation for proportion is p hat minus p divided by the square root of p times 1 minus p divided by n. So we know p equals 0.2 because we established that in the null, but we don't know what p hat is. So we need to take a second and go find p hat. So p hat is x over n, where x is the number of individuals with the desired characteristic. So we desire to find people who smoke. So we had 76 smokers out of the 400 that we surveyed. So that gives us 0.19. So now we can go ahead and calculate this z data or this z-score. So we're going to take our p hat, 0.19, minus our p, which is 0.2. We're going to divide that by the square root of 0.2 times 1 minus 0.2 divided by 400. Okay, and then let's go ahead and do the top and the bottom separately. Keep as many decimals as you can in your bottom. I know in the past I said I'm okay with you rounding this bottom piece, but for your homework, it's going to be a lot better if you don't round anything. So in this case, we don't really have to round much in that bottom because it's just 0.02. So negative 0.01 divided by 0.02 is going to be negative 0.5. So now this is where the probability piece comes in that we talked about. So I know that I'm half a standard deviation below the mean with from my survey, my sample proportion compared to the proportion from the null. So I need to find, is the probability too small? So this is a left-tailed test because of this less than sign in the alternative. So I'm going to go into my normal CDF, and I'm going to treat this as a less than question. So a less than question, we start with negative 1 million, which remember represents negative infinity. We're going to finish with negative 0.5, and then we have 0 and 1 because we've calculated a z-score. And we get 0.3085. So the probability that I find a proportion of 0.19 or lower, assuming 20% of the population still smokes, is 0.3085. So for my conclusion, shouldn't have done that in purple. I'll change it on the next problem. I need to ask myself, is 0.3085 less than my alpha, 0.10? In this case, it is no. If your p-value is not less than alpha, that means the probability is not too small, so we do not reject. So we're going to write a final statement that says, do not reject the null and conclude I don't know why it's not, for some reason it's not letting me undo. Conclude that the proportion of Americans that smoke is not less than 20%. And the language on that last piece, the not less than 20%, goes back to the idea of this being similar to a court case. We would not want to say that it is equal to 20%, because that's like the juror standing up saying he's innocent. We're not going to say that. Okay, just like we're not going to say that we accept what's in the null hypothesis. We want to say that we do not reject the null, meaning we did not find that the null was false. Therefore, we cannot conclude whatever is in the alternative. So this last piece of information is always going to start with the conclusion. Either you are rejecting or you are not rejecting the null. And then we conclude that the proportion of whatever it is you're looking at either is whatever you said in the alternative or is not whatever was said in the alternative, based on whether you are rejecting or not rejecting. If you are not rejecting, then it ends with is not whatever is in the alternative. So our alternative was less than 0.2. Up here, less than 0.2. So the proportion is not less than 20%. Ooh, I don't know what I did there. Okay. All right. So there is one example of a hypothesis test. This is an example of a left-tailed test. Let's move on to the next example and see how things change. So two major college entrance exams that a majority of colleges accept for admissions are the SAT and the ACT. An official with the Illinois State Department of Education wonders whether more than half of the students in her state are prepared for college algebra. She obtains a simple random sample of 500 student records and found that 289 of them scored high enough to take college algebra. Does this represent significant evidence that more than half of Illinois students are prepared for college mathematics or college algebra upon graduation? Use alpha equals 0.05 level of significance. So we're going to start this problem just like we started the previous problem, by going through and highlighting all of the important bits of information. So the first sentence is just some background information about what it is we're looking at. Okay, so then the next sentence we see that she wonders whether more than half of students in her state are prepared for college algebra. She obtains a simple random sample of 500 students, and she found that 289 of them scored high enough. Does this represent significant evidence that more than half of Illinois students are prepared for college mathematics? So again, we have this more than half. Okay, half is a proportion. Half of the population is 0.5. So if you ever see a problem that says more than half, that means you're looking at a proportion. Okay, and then another key, does this represent significant evidence? That tells you you're doing a hypothesis test. It may not specifically say test this hypothesis. It may say, does this represent significant evidence? That's another way we can word the question to say, hey, we're going to do a hypothesis test for this. And then alpha equals 0.05 level of significance. That's another piece that would tell you this is going to be a hypothesis test, level of significance. All right. So let's go ahead and start that hypothesis test. All right. So step 1, write out the null and alternatives. So our null is going to be P equals 0.5, because we want to know, is the proportion equal to half? We're going to assume that half of students are prepared for college algebra. And we want to test if that proportion is actually greater than college algebra, greater than 50%. Okay? Sometimes it's actually easier to look at what is the alternative hypothesis going to be first, because we see this more than half. Okay, so it's totally okay to write out the alternative first and then work backwards to figure out the null, because if you notice, the alternative is the same parameter, still P, and the same value. The only difference is it says equal to. So if you're reading the problem and you get stuck and you're like, I don't know what the null should be, see if you can figure out what the alternative is. See if you can figure out what it is that you're testing. And then work backwards from there to figure out the null. So now, step 2, we want to verify normality. Verify we have a normal distribution. I'm going to alternate colors. So we want to do our n, which is 500, times p, which is 0.5. That equals 250, which is greater than 10. And 500 times 1 minus 0.5, which is also 250, which is also greater than 10. So this is normal. So we don't have an issue there. So we can move on to step 3, which is calculating that test statistic. So z equals, we have to do something first, and I didn't leave myself enough room for it. Before we can figure out what z equals, we need to find what p hat equals. So p hat is going to be the number of students that scored high enough over the total number of students that were surveyed. 289 over 500 is 0.578. All right, so now we can plug that in. So 0.578 minus 0.5. This second number is always going to be whatever your null is equal to, because p equals 0.5. So when we go to our z-score equation, this value is p. and then the square root of 0.5 times 1 minus 0.5 divided by 500. And remember to take the square root of that. Okay, so this first piece on top becomes 0.078. And we divide that by the square root of 0.5 times 1 minus 0.5 divided by 500. 0.02236066798. So we want to use all of that. I'm going to do 0.022 ... So 0.078 divided by that value, 0.223606798, and we get 3.4883. At this point, you can round to 4 decimals. So don't round throughout, just round when you get to your final z-score, just like before. All right, now we want to go ahead and calculate the probability of being greater than this value. And it's greater than because the symbol in our alternative is a greater than symbol. So we're going to go ahead and go to our normal CDF. Our first value is going to be 3.4883, followed by infinity or 1 million, and then 0 and 1. So 3.4883, 1 million, and we get a very small number, 0.0002. So now we can go to step 4, and in step 4 we have to ask ourselves, is 0.0002 less than the value of alpha? And it's less than because we want to know, is our probability too small? Okay, this less than symbol has nothing to do with our alternative. Okay, the alternative piece, the greater than, came in when we calculated this probability. But now we're asking ourselves, is this probability, oh my gosh, I'm sorry. Is this probability too small? Is it smaller than alpha? And in this case, the answer is yes, it is smaller than alpha. So we're going to go ahead and reject the null hypothesis. So reject the null, because the probability that I got the result that I got, assuming half of the students are prepared for college algebra, was too small. It was too small of a probability for me to have seen this proportion of students be ready. So reject the null and conclude that more than half of students are prepared for college algebra. And that is it. Okay? So the difference between the previous question and this question was the previous question was a left-tailed test. So when I calculated the probability, I did negative infinity and then my z-score because it was left-tailed. So we want everything less than. This problem was a greater than. So I started with the z-score that I calculated and then put in infinity or 1 million. So I calculated the probability of everything to the right of my z-score. All right, so one more example. In a survey, 45% of respondents stated that they talked to their pets on the answering machine or telephone. A veterinarian believed this result to be inaccurate, so she randomly selected 150 pet owners and discovered that 63 of them spoke to their pet on the answering machine or telephone. Does the veterinarian have enough evidence to say that the proportion of pet owners that talk to their pet on the answering machine or telephone is different from 0.45? And excuse me for a second, I have to get my cat to stop clawing me. All right. So use alpha equals 0.01 level of significance. So highlight important information in this problem. So 45% of respondents stated that they talked to their pets. The veterinarian randomly selected 150 pet owners and discovered that 63 of them spoke to their pet on the phone. Does the veterinarian have enough evidence, so hypothesis test, to say that the proportion of pet owners that talk to their pet is different from 45%? Alpha equals 0.01 level of significance. So we have our 4 steps. There's going to be a big, oh wait, I can fix this. I forgot about this. I can fix this. Hang on. Go over it with white. I'm so smart. Okay. Step 1. Write out the null and alternative hypothesis. So our null is that the proportion is equal to 45% or 0.45. Our alternative is that P is not equal to 0.45 because the key word in this problem is different from 45%. Step 2, verify normality. We may run into a problem with this one. We'll find out. So our N is 150 and our P is 0.45. Oh no, we should be fine. 150 times 0.45 is 67.5, which is greater than 10. 150 times 1 minus 0.45, that's going to be 150 times 1 minus 0.45, 82.5, which is also greater than or equal to 10. So our distribution, again, is normal. That's good. Step 3. Calculate your test statistic, but first figure out what your p-hat is. So 63 out of 150, 0.42. So now plug all of that into the z-score equation on the first page. 0.42 minus 0. Okay, we're just going to start that over. 0.42 minus 0.45 divided by the square root of 0.45 times 1 minus 0.45 divided by 150. So this top piece becomes negative 0.03. And the bottom piece, go ahead and calculate this with me. 0.040620192. So 0.04 ... Use all those decimals. Negative 0.03 divided by our answer. Negative 0.7386. All right, now this is where this gets a little tricky. This is just the case where it was too low. So what we're going to do is we are going to do our normal CDF. And because I got a negative z-score, I'm going to treat this as if it were left-tailed. If I had gotten a positive z-score, I would treat this as a right-tailed test for this purpose. So because it's negative, we're going to start at negative infinity, negative 0.738601, and we should get the correct answer. The first time I did these notes, I did not get the correct answer. Haha, 0.2301. But this is a two-tailed test, which means we have to consider the fact that it could have been too small or too large. So what I need to do before I can compare this value to alpha is I need to multiply it by 2. So 0.2301 times 2. 0.4602. And now this is what I'm going to compare to alpha for step 4. And I've run out of room. That z-score equation was too big. So is 0.4602 less than 0.01? No. So we do not reject. And this part gets a little funky too. So do not reject and conclude that the proportion of pet owners that talk to their pet I'm going to have to do a ... This should say of pet owners that talk to their pet on the telephone or answering machine is not different from 45%. And that goes back to, we're not going to say it's true, we're just going to say that it's not false. Okay? So biggest difference here is it's a two-tailed test, which means we have to consider the probability that we could have gotten a value that was too small or too big. So when we found our probability using normal CDF, because I had a negative z-score, I treated it as if it were left-tailed, and then I multiplied that probability by 2. Two-tailed multiply by 2. And then I went and I compared it to alpha. So that is all I have for 15 part 2. So we went through an example of each of the ways to set up a hypothesis test. So that is it for these notes.